Renee Weber is a professor of neuroscience at the University of California, Santa Barbara. He's conducted a study into what's happening in a person's brain at the very moment they're playing a violent video game.
We had people in a brain imaging scanner, and while they were in the scanner, they played a first-person violent shooter game. And while they played, we scanned their brains. And then afterwards, we analyzed the distinct pattern of playing, such as violent interactions or non-violent interactions, searching for your way out of this maze, or engaging an opponent and killing this opponent.
Weber wanted to see how the brain responds to virtual violence as it happens. No one had tried this before.
I went into the study and thought there is no way that we ever see a consistent pattern because just by the nature of the stimulus, it's a very complex stimulus. There's a lot of auditory, visual information. You have to make decisions in almost every second of gameplay. So I thought it will be a really hard study to do.
Amid the noise, one clear response began to emerge. From previous studies, Weber knew violence would usually cause this area to activate, the amygdala. It's involved in processing our emotions, like fear. But when he observed gamers in the scanner, Weber saw a different section light up, part of the anterior cingulate cortex. It connects the reasoning areas of the brain to parts responsible for our emotions. It appeared to suppress the amygdala's normal response to violence.
In any instance of a violent engagement, we saw pretty much the same pattern in all but one participant. That's amazing. It looks like that there is an active suppression of the more emotional processing centers in your brain.
Whenever his subjects committed an act of virtual violence, Weber observed the reasoning parts of their brain suppress their normal emotional response. So here, finally, was clear evidence that playing a violent video game has an effect on our brain. But is this particular brain response exclusive to aggressive behavior? Simone Kuhn is professor of neuroscience at the Max Planck Institute in Berlin. She has observed that this brain pattern isn't unique to playing video games.
You can also find a reduction of amygdala when people voluntarily suppress emotions. I mean, if you just see somebody crying and you don't want to feel this, you reduce your amygdala activation. That just means you're regulating emotions. It isn't even specific for aggression, to my opinion, but always occurs whenever you try to modulate your emotional response.
The brain pattern that Weber observed in his scans is not unusual. It's involved in regulating our emotions in many different situations. It doesn't prove that a video game can make us violent in the real world.
So, do I show with this study, with this pattern, now I found that we are aggressive after we play a video game, or we are desensitized after playing a video game? I did not show that. That's not a conclusion of this study.
So even looking inside the brain at the very moment we're playing a violent game hasn't provided conclusive evidence of a link to violent behavior. Around the world, the hunt is on to find the hidden benefits of video games. Professor Simone Kuhn has turned her attention to a game that tested the navigational abilities of the player.
We recruited about 48 subjects, divided them randomly into two groups. One group was asked to play the video game Super Mario 64, and the other group was set to do nothing. And we basically put them into an MR scanner before and after the training phase of 2 months and looked at brain changes.
Professor Kuhn wanted to see whether playing the game would cause changes in the brain. Specifically, in the volume of particular areas.
In general, more volume means the brain can get more active in that area. So if you have an active brain area for long, this tends to increase in volume.
An increase in volume indicates that part of the brain has grown. Could this really be achieved by playing a video game?
We indeed found brain growth. We found increases in the right hippocampus over here, which is a brain region that is particularly involved in spatial navigation, in orienting in your world. Another brain region that increased in that experimental group was the prefrontal cortex on the right side. That's an area related to strategic planning. And the last region is called cerebellum, and that's particularly renowned to be involved in fine motor tuning in a way. I mean, really handling the joystick well.
Professor Kuhn discovered that playing the Super Mario 64 game had caused 3 areas of the brain to grow. This is an example of what neuroscientists call brain plasticity. It's the ability of the brain to reorganize, and in some cases grow, in response to incoming information from the senses. Professor Kuhn believes the game had this effect because it forces the player to navigate in a very particular way.
So on the upper screen, you see a sort of 3D view of the world where your avatar walks around. And on the bottom screen, you see a map-like view that indicates where your position is and where, say, the star is that you need to collect. And you need to integrate these two perspectives, which I think facilitates navigation processes and therefore enhances brain regions that are related to spatial processing.
This study is part of a growing body of work that has led Professor Kuhn to a far-reaching conclusion.
We have been struggling for a long time to find tasks that people can play to improve cognition, and we've largely failed. Video games seems to be better because people train the same function in very different contexts and then are better able to transfer it into real life. This, I think, is something we should use, and we should use for all age groups.
The work of Daphne Bavelier and Simone Kuhn suggests that playing video games can improve our cognitive abilities. No matter how old we are, it's an enticing proposition. Could video games be used to help combat mental decline as we age?